I want to take a few minutes to give some overall feedback on the lens investigation in addition to the email feedback that I sent to many people. So overall, this is kind of an overall summary, and I'll zoom in a little bit more in our details here in just a minute. But here are the various different cases that you set up for converging and diverging lenses and how those images formed. Looking at some overall patterns, as long as your object was beyond the focal point, which it was in the first three cases for converging lenses, then notice the image you form in each of those cases is a real image. So most of the time that you have a converging lens, you're going to get a real image. You know that it's a real image because the rays of light go through the lens and they converge together on the other side to cross, and where they cross, that's where the image forms. I also want to note that all of those images are also inverted images, and that was one of the questions. Whenever you have a real image formed by a single lens, it will be inverted. Now the size of that image is going to change, okay, but it will be inverted. Now let's look individually at some of the diagrams so you can see them a little bit better. So here's the first case when you were at a location somewhere farther than 2F, and the rays come together and your image forms right there is the image of that candle. It is reduced. You can see it by size. You can also see the measurements here. Your object height was 10 centimeters. Your image height is only 4.2. It's negative, which means inverted. Here's the next case zoomed in. When you are exactly at 2F, which sometimes takes a little bit of manipulation to move around, your object height of 10 centimeters, your image height of negative 10 centimeters. So we know that is the same size. When we move the object between 2F and F, now our image continues to move out farther. Previously it was at 2F, now it's way past 2F, all the way out there at 52.2 centimeters, and it's progressively getting larger, but all of these images so far were inverted and they're all real. In the next case, where you put the object at the focal point, looking at the diagram here on the left, this object is located exactly at the focal length. It's at a distance of 20 centimeters. The focal length is 20 centimeters also. But the simulation is showing some things that aren't actually going to happen. It's showing that this ray somehow goes to the lens and appears to reflect off, and this ray right here is doing a couple of different things. So then I would have told you about this earlier, but I did not see that it was doing that. I'm going to say this is wrong, and what I have in the diagram next to it is an object that is really close to the focal point, but a little bit off, and it's showing what the rays would actually do at the focal point. Your top ray, your parallel ray, would refract through the focus. The second ray down, the optical center ray, would go straight through. And then the third ray, the focus ray, would basically never hit the lens. Now, the image here, there's an arrow out, and this image distance is very, very large. Ideally, that would be, if you were at the focal point, an infinite distance away, as indicated on the other diagram. So then basically what that means is that the rays refract parallel to each other. And if they are parallel to each other, they never intersect. And if they never intersect, then you have no image that is formed. Instead, you get a beam of light. So this would be an application like a flashlight, whereby you have the light bulb and you get a beam of light coming out from that. A lot of those are done using mirrors, but if you have one that's using lenses, that's what it would look like. Same idea on the headlight of a car. You get a beam of light. Now, when you move that object inside the focal point, so our object here, I just want to emphasize that is the object. So it's between F and the lens itself. Then the image that you get is out here. This image happens to be somewhere close to 2F. It's not exactly there. It's somewhere on the same side of the lens as the object, but you can see now it is upright. You can see that it is enlarged in size. I also want to emphasize this is a virtual image. Now, we know it's a virtual image because notice what we had to do. If you are over here viewing this image, your mind is going to have to follow those rays back. Notice the dashed lines here. This is a projection of where your mind would be following these rays back, and the light does not actually travel there. Okay, that's why it is a virtual image. All the other ones, we followed those rays of light to where they came together and they actually intersected to be able to form that image. Here's your diverging lens, and again, the dashed lines. So the image forms on the same side as the object. Here is your object, and here is your image that forms. And that image forms somewhere between the focal point and the lens, but the rays of light have to be extended back. So it is virtual, it is upright, and you can see by the size and by the numbers that it is reduced. Now, just recapping a little bit on the other questions. Real images are always inverted. Virtual images are always upright. For a converging lens, as the object moves closer to the lens, staying outside the focal point, the image is going to move further away from the lens, and the image is going to get progressively larger. Diverging lenses, as you move that object closer, that image is going to be penned in and move even closer to the lens. Question number 12. Diverging lens, explain why there is only one thing that happens for the image. Basically, there's only one thing that happens because as those rays refract through the lens, and I'm going to go back to our diagram, as those rays refract through the lens, these rays on the other side get further apart, and because these refracted rays are always getting farther apart, then the only place they can come together or appear to intersect would be behind the lens. So if they're always coming together in a single location on the other side of the lens, because they diverge, there is only one thing that can happen for that image. So there were a number of questions on that number 12, so I just wanted to make sure to clarify that. Ponder physics.